Hi, welcome back with Mr. Canada Maths. We're still doing fractions, decimals, and percentages, but we're looking at a special case called recurring decimals to fractions. So we've seen this when we went fractions to recurring decimals, what that kind of looked like. But what about if we have a recurring decimal? How do we write that as a fraction? So, the different ways we can see recurring decimals first, if you forgot, are the following. So 0.8, when the dot just occurs over top of the number, that number will keep recurring. If, in the next case, you see there's a dot above two numbers with this 0.82, it means that it's going to recur 82, 82, 82 in that order from left to right. What about now if we have 9 and 6 are underlined? A dot, I mean. It actually means that everything in between, everything starting and ending there. So here it goes 916, 916, 916. And lastly, well, what happens if the dots aren't, we have some other numbers too, and it's then the dots? Well, we just write those other numbers. So we have this 0.17 as this 0.17. Then we have our 248 as 248, then 248, then 248. A common thing when we actually go to write these out is to write out at least 3 of the numbers. So for the first one, I would write that out as 0.888, and then show some dots just to show that, hey, I know this keeps going on, but that's just actually when we go to calculate. So how exactly are we going to do this? So convert 0.8 to a fraction. So this is that very first one, so we're going to write the decimal out as a long list of repeating values, and we're going to set it equal to x. Now, I know this might be a new kind of idea, but this is kind of one of the purposes of algebra. We're choosing to set our decimal as this unknown, okay? And you'll see why this becomes so cool. So we have this. Now, we want to take this expression and multiply each side, okay? So just like a fraction, we'd multiply the top and bottom. We're going to multiply each side. So we're going to go 10 times by, and that's our x, right? 10 times by our x equal to, and we're going to do 10 times by, and this 0.888, and keep going, right? Well, on the left, that's quite simple. 10 times x, we know with algebra we can just take out the multiplication. So we get 10x. And on the right side, you might think, I don't know what to do with this. It keeps going on. I've never dealt with multiplying by something that goes on forever. That's impossible. Well, if we multiply by 10 or 100 or 1,000, it stands to reason that we just move the decimal place, right? So we multiply by 10, so we move the decimal place once. So that means we're just going to have 8.888. And that's going to keep going on, right? It's just saying if 1x is 0.888, then if we add all those together, we're going to have 10x's, and it'll move the decimal place once. We'll get 8.888, right? So here, we have x equals, well, 0.888, right? And 10x is 8.888. So I just wrote it up with 3. We know it keeps going. So if the values after the decimals in x and 10x match, so that means after the decimal place, we're just looking over here, right? We don't care over here right now, and we don't care what's happening over there. So it's 888 and 888. Then we can stop. So if not, we'd have to take our 10x and multiply by another 10 on both left and right. And hopefully they'll be the same. So because they do, we're going to skip. So subtract the two equations. What this means is you have one equation. I'm going to just copy them down so we can see them. And I'm going to give some labels. So here we have 10x equals 8.888. we have x, and that's equal to 0.888. So if we call this maybe equation 1, equation 2, we are going to do 1 minus 2. So that means we're going to break this up into two problems, basically. So ignore these right now, and let's just look at this left-hand side. So what happens when we have 10x and we take away 1x? 10x minus 1x is simply 9x. Then let's just look to the right side. Well, let's look over here, and let's just consider something, okay? So these dot dot dots, we know that these 8s are going to keep going. But if we subtract this 8 from this 8, those will cancel out and get 0. This 8 from this 8, that'll get 0. That 8 from that 8, that'll be 0. So it stands to reason that all these dot dot dots are all going to be zeros off forever, right? So this is why we want these to match, because the second that we get the decimals to match, we can stop writing them as a recurring number. We've gotten rid of the recurring. So let's just keep going. Well, decimal minus decimal, that goes away. 8 minus 0, well, that's simply 8. So we really are left, I'm going to rewrite this down here under step 5. We have 9x equals 8. Okay? That looks really nice. So how do we want x by itself, though? So the way that you do this, whatever numbers outside are x, we divide by that, because we know that any number over itself is 1. So we'll get back 1x. But because we divided the left by 9, we divide by the right by 9. And you'll look that, hey, look, x equals 8 over 9. So that is our fraction for 0.8 repeating. And you can check this by putting that value in your calculator, and you'll see that it actually puts that little dot over top. Or you'll see the string of numbers just keep going on and on. So let's do a second example. So example 2. So right away, I am going to set x, and I'm going to say that equals 0.83, and the 3 keeps going, right? Here. Then I'm going to take 10 times by this side and times this side by 10. So below I have 10x. So now I have 10x. And that equals 8.333, and it keeps going, right? So let's check. Well, these match, but these don't match. These next ones don't match, so we can't do that. So I'm actually going to go back, and we're going to have to take this a further step. So now we have x and 10x, and I'm doing mine in a different color just so you can see where I'm going to write all these out after. So we have 10x, so here we're going to have 10 times 10 is 100. And here, once again, we're just moving the decimal place one more time, so we get 83.333. Okay. So now, not only do we have their original x as blah blah blah, right, 0.83, we have this next one, 10x is 8.3 recurring, and then we have this 100x is 83.3 recurring. So we can compare any of the equations. We do not have to use this first one right here. We do not have to always use that, and I'm not going to. Because if we take, say, this, and say that's number 2, we can go 1 minus 2, and we'll find out our answer. So I'm actually going to rewrite that as 100x. And if you prefer writing it out left to right, that's fine. It's just as you get higher and higher into your maths, you'll see it written top down like I did up here, or sorry, up here, above there, you'll see that happen a lot more. But 100x minus 10x, and then on the left side we have 83.333 came first, right? Minus 8.333. And we'll see that we have 90x on our left. And on our right, everything after the decimal place is vanishing. So we have 83, and we take away 8, which is 75. So now we divide by 90, because that's outside of our x. So we divide by 90 on this side. So we can say that x is equal to 75 over 90, which is the same as saying 15 over 18, which is the same as saying 5 over 6. So last example we'll go through is here. So here we set x equal 0.872, and keep in mind the 72 is recurring. Okay. And I always write out 3 of them just to see that, hey, for sure that that's the recurring part. Then we can say right away 10x equals, well, 8.727272, right? So we just keep timesing by 100. So you don't actually have to show it. If you can just see what you're doing, you just start stating it. So 87.2727. Well, that still doesn't help us. We have to keep going. Let's go to 1000x. So sometimes it's really convoluted and you got to do a lot. So 87.2.7272. So which two match up? Well, it's this guy and this guy. 1000x and 10x. So let's do 1000x. Take away 10x. And that's going to be equal to, what's on our other side? 872.72. Sorry for my pen being a little slow. And we're going to take away, what is that? 8.7272. Okay. So let's subtract those. So on the left side, we are going to result in, what is that? 990x. And that's going to be equal to, well, everything on the right vanishes. If you like, you can put lines through it if it helps you, so you don't when you're subtracting. So 872 minus 2 is 870, so we take away 6 more, so 864. And then we can just divide over. Divide by 990, divide by 990. So we can then continue on simplifying. So even though it looks really difficult, like I said, with really difficult problems, to simplify them quickly and painlessly, just divide by 2. Because then we can find that that is what, 432 over 450. Divide by 2 again. 216 over 225. And now you can just think, well, what makes up 25? Well, that's 1, 5, and 25. None of those can make up 16, so we're actually done there. Okay, so here are 6 for you to try. When you're done, we'll go through some of the answers. Okay, welcome back. So here we state x equals 0.333. Then we have 10x equals 3.333. When we subtract them, we're going to find 9x equals 3. So x equals 3/9, which equals 1/3. We've dealt with 0.3 repeating a lot. Here we have 0.7 recurring. So some people, they see that and they're just like, oh, I know how to do that right away. That's 7/10. No. So equals x. Doesn't matter which side you have your values on. X's can be on the left or the right. You can move them around as long as you keep them the same. Sorry, that's 10x. So here we're going to subtract them. We're going to find that 9x is equal to 7. So x equals 7/9. So moving on, we have 0.27. So we have x equals 0.272727. I know that 10x won't do it, so 100x will, and I'm going to get 27.272727. So subtracting those, I get 99x equals 27. So x equals 27/99, which is equal to 9/33, which is equal to 3/11. Moving on, 0.72. So same thing. We have to use x and 100x. So that's 72. Subtract them, we get 99x equals 72. So x equals 72/99, which is equal to, what's that, 27, 27, 27, oh, 36. So that's going to be equal to, well, 24/33. Right, when we divide by 3, then we can divide by we can divide by 3 again, and we can get 8/11. Here, keep in mind this changes the problem. Here we're doing 0.7. 2 is equal to x. 10x is then 7.2, and 100x is 72.222. So 100x. So we're going to get, when we subtract 100x and 10x, we get 90x, and that's equal to 70. Right? Oh, sorry, 65. So we get x is equal to 65/90, which is equal to 13/18, and we're done. And lastly, this is going to be a nice one, so I'm going to give myself a little bit more room. So we have x. We have x equals 0.38232. So by times by 10, it'll move it here. 100 will move it here, and then 1,000 will move it here. So that's what I'm going to have to do. So 1,000x is equal to 382.382 ... Right? So that means I get 999x is equal to 382. So here x is equal to 382 divided by 999. So that one for simplifying, we can't simplify it by 2, we can't simplify it by 3 or 4 or 5 or 6 or 7, 7, nope, 8, 9, 10, nope, so that I think is actually in its simplest form.